Okay, quick explanation of the navigation stack. This is the move-based ACAN navigation stack. It has a global planner, a local planner, the global and local cosma, the recovery behaviors. All those nodes move forms the move base. The inputs are the TF and the ODOM, also the map, but it's not necessarily, and also some noise such as the laser scanner or the point cloud. The outcome will be the publishes publishes it publishes the command velocity uh, uh, to the command velocity topic, the command to control the robot. So also another input of the uh, move base node is the AMCL. And then the next thing we need to know is that we are using two types of local planners. One is the dynamic window approach or DWA, and the other one is this one that is called TEB. It's both are local planners. So for TEB, I follow the ROS tutorial guide. So let's see how to practically you need to make one base local planner with the parameters of the robot, the cost maps, with the topic that you are publishing, your laser scan or your point cloud. For dynamic window approach, we have to adjust these parameters. Right now, I didn't adjust any one. These are the default values. Also, we have the global cost map parameters. We can adjust the robot frame and also the global frame. The same thing for the local cost map. Parameters of the move base node. And also, if we were using TEB, we have to adjust all these parameters. So it's a little bit complicated, but at least work. It's not perfect because I have to fine tune. So the first thing is to launch the simulation. I have a separate video explaining that. And the next thing is to launch the navigation. You can input the local planner, DWA or TEB, but by default is DWA. So we start here. We have the pose of the robot right here. Next, we have to plan. I will do a short plan just to demonstrate that the robot is planning because I want to finish this video quickly to upload the repository files. So here the robot start planning. This is the Cosma, the local Cosma, the robot Cosmap, the local plan, and this is the global plan. So it is planning to the goal position and moving. We are seeing that the particles are getting near the robot. That's good. And we're done, I think. Okay. The next thing is to test the TEB. So for TEB, the same procedure. We launch the simulation, the gazebo simulation of the Jetbot. And the next thing is to launch the navigation stack with the TEB argument in the local planner variable. So the same app, we have to put here the pose estimate. Let's change here the local planner to the let's see, local planner. This is the global planner. Okay, change the global planner to the global plan, and also the local planner to the local plan. Of course, the TEB. Well, next again, we need to plan something. So let's plan here. And we see that this is the global plan, this is the local plan. He will turn a little bit here and that way. Let's see how it goes because it's a pretty old plan. So the particles are converging, that's good. That means the control loop is doing a little bit accordingly to the position of the robot. Okay, they are converging, that's good. Okay, that was pretty neat. I demonstrate here that we got our navigation stack working with TEB and DWA. We have to fine tune the parameters. As you see, there's not pretty good the navigation, but at least it's going from start point to goal. So hope you like the new feature of the repository. Try to do your own navigation stack or use my Jetbot implementation. Thanks.